So what does dynamics do here? What dynamics does is it tells me how I leave this space in general. There is a special case of interest where you don't leave it. So dynamics just does its own thing. So time t later, I'm at x of t, which is, f of t having started at x. So I'm at some other point and I go in. And that point has its own stratum, because dynamics have changed the shape of my solution. I used to be like this, but now I'm like that if I'm describing swimming, for example. The time dynamics is very rich, while symmetry is rather simple. So, in our world, the spatial symmetry is something I can walk around the room and I can be the same person if I place myself at various angles. Dynamics is shape changing. It does something. So what it does is it explores the whole state space, whereas the group only foliates it. The importance of continuous group only became appreciated with the advent of quantum mechanics. I mean, of course, people use them in classical celestial mechanics all the time because you have datations and translations there. But in quantum mechanics, this became totally essential. So by 1920s, Hermann Weyl and then Wigner later, they formalized this whole subject to be suitable for application in physics. Until then, physicists even didn't know what a matrix is. They only solved differential equations. They had no idea what linear algebra, etc. It's all thanks to quantum mechanics that came in. Dynamics explores the space of group orbits. So you have to think of your state space now as a head of cabbage with the leaves of cabbage. And then when you put the wand through it, it'll go through different leaves of the cabbage. That's what dynamics does.